a good union, so he gets to take a lot of breaks. So let me see. Let's do a couple more that's a little more involved. Let me see what you guys think about this. I don't know where I am, but in terms of numbers, let's see. Well, if I had this. This is where people just sort of give up a little bit. But if the problem was just this, I would hope nobody would just give up. If the problem is just this, well, that's a little bit freaky. But still, I'll tell you this. Whenever you see something that looks like this is loaded with letters all over the damn place, what do the negative power things want to do? That's the first thing I do. So kill all my negatives so I don't make a negative mistake. Right? So before I do anything else, I identify what wants to flip. This is the only part of this that wants to flip, right? Why does it want to flip? Because it's got a negative power. So this is going to go up. So I can rewrite this as a squared, b cubed, b squared over a5. Let me let you guys, do you guys see that? Nothing amazing there. We've already talked about why negative power means flip. So now when you see something with a negative power, you immediately flip the damn thing.
Just that one, not the 5.
Is anything else to the negative power? What's the only thing that means flip with powers?
Sounds like the A and the B were together. So
No. 2 times x. Those are like together, right? But can't I divide and kill part of it? They're not like inseparable. Do you see what I'm saying? I can certainly move that up here. Yes.
Why didn't we just put that B on top of that other B and just make it B5?
Yeah.
Well, I love it. That's what I would do, but I just want to make sure that people see where everything's going and coming from. I already got 3 B's. This is the way I say it to myself. I got 3, there's 2 more coming, I got 5 at the end. So if you want to skip the step I just wrote, that would make a little cry of joy, right? But I don't want to skip a lot of steps when I'm explaining something. So it's the same problem. It's just that everything to a negative power has flipped, because that's what the hell a negative power does. Now, like you guys said, how many B's do I got up there? 5. Now look. Now watch.
You cancel?
Don't do 2 minus 5 bullshit. Do how many A's cancel?
3.
Well, how many A's are left is 3.
2.
Right? 2 A's cancel. How many are left? 3. Where?
Negative.
On the bottom.
Yeah.
You could either say 2 minus 5 is A to the negative 3, but then what would that have to do? That would have to flip. I'd much rather just say there are 3 on the bottom. Done. Right? Don't 2 A's cancel?
Yeah.
How many are left?
3.
On the bottom. Now, if you do 2 minus 5 is negative 3, that's fine, but won't this have to flip to the freaking bottom?
Yes.
So why not just put him there in the first freaking place? Right? Maybe. Alright.
So that's the answer.
Yes, that's it. There's nothing else I could do. There's different bases now, so I can't do anything between those. I like it. Now, to be completely honest, this is something you guys should have done a lot of before. Right? But if you've never quite understood why it works the way it does, I'm hoping you're picking that up from here. Let's see, what have I left out? There's one more property we haven't talked about yet, and that is this guy here. Actually, wait, we haven't talked about, let's do this property first. That property, and then we'll do the other. So this is where people especially get confused about what to do with the 2 and the 4. But what does this mean? What does that 4 out there mean? It means I have 4 of these.
Yeah.
Right? So I don't ever do this, but this is why it works the way it does. I have 4 of these multiplying, right? So then how many do I end up with? X's? 8. That's the freaking definition of multiplication, right? 4 groups of 2 is 8. That's how you first learn multiplication. So when you raise something with a power to a power, you multiply the powers. When I multiply a power, what do I do with the powers? Yeah. Like, those are so easily mixed up.
Yeah.
So the parentheses mean multiplication and then no parentheses.
Well, this means this to the 4th power, right? But what does something to the 4th power mean? It means 4 of them multiplied. So I would end up with 4 groups of 2, which is 8. So it's a shortcut. Multiply those numbers. I like it. And then I can extend that to this. I don't know what happened there before. Now, real quick.
What is this property called?
Power distribution. That pretty much gives it away there, but let me see if you guys can handle it a little bit more. Watch this. Distribution power property is normally one that people love. So if I had this, do you see how it's sort of related?
Mm-hmm.
If I had this though, wouldn't that be easy?
Yeah.
What would this be?
10x
10x.
plus
15y.
15y.
What is 5? Well, let's see if you guys remember. Don't say the word times. What is 5 based on? What is 5? What's the operation that 5 of what doing what? What's adding? So 5, this coefficients are based on addition. That's why they work well with addition. What are exponents based on?
Multiplication.
That's why they work well with multiplication. So the same way I could distribute this 5 through, I could distribute this 5 through. What's x squared to the 5th power? What do you do with those powers?
Multiply.
Yes, x to the
10.
10th, y to the
15.
15th. Do you see the symmetry there, the analogy there? It's distribution. So why can I distribute coefficients across addition or subtraction? Because that's what they're based on. Why can I distribute powers across multiplication? Because that's what it's based on. They play well with multiplication because they're based on multiplication. Okay. Let's see how weird things get. Let's see, what is it? Number 27. Oh, okay. Let me show you. If it was this, x to the negative 3 times x. Be really careful when there's no exponents. What do we understand is up there? So you should write it for yourself so your brain doesn't think 0. So I know there's a 1 there. We just normally don't write it to save time. So what would this come out to be? X to the negative 2, which I can write as, good, 1 over x squared. I like it. Let me let that sink in. Right, because what do you do when you have like bases and you multiply? You add the powers. And then what's the negative power mean? Flip. I like it. The problem is actually this. What's the 3? Yeah. It's the same damn problem. But there's a major mistake people make. So let me see. I'm not trying to trick anybody, but first off, what should I put up there for myself? There's an understood 1, yeah. So let me just help you out. And that's good. I'm glad you said something that was right. I mean nothing against you, but it's so easy to make this mistake. I'll see somebody write this. That's crazy. That's absolute craziness. I don't see any freaking 9s. Right? I'm not actually multiplying the 3's together. I'm keeping track of how many 3's I got. So you wouldn't have a 9 to some power. This is totally wrong. I don't see any 9's. How do you get some here? So what do you have? 3 to the negative 2, because the base doesn't change, does it? You're just collecting how many of that base you got. And of course, this is the same way. It's 1 over 3 squared, which is 1 over 3 squared? 9. That's 1/9.
So you have to get all the way to 1/9 to get the answer right.
Exactly. It's not that long.
So you don't
I feel like an old man. In my day, we walk uphill. I mean, this one-line problem, those are beautiful. When you get to the problems that take up 3 pages, then you can complain. What's up? Okay. Does that make sense about that? I mean, that happens a lot. Like if I had this, 7 to the 4th over 7 squared. I always get somebody to cancel the 7's and say the answer is 1. That doesn't make any sense. 7 to the 4th is huge. Divided by 49 should be something way bigger than 1. Right? So what's the right way to do this? Well,
Subtract.
Subtract, and then you end up with how many whats?
2.
2 sevens.
Yeah.
The base doesn't change. You're just keeping track of how many of that base you got. Yes, sir.
Often the base is not the same. So say.
Oh, I like it. Beautiful. Say what? Give me an example.
5 squared, 6 cubed.
You just can't consolidate it. You actually have to just figure out what 5 squared is. Or there's no way to consolidate that. You could not say this is 30 to the 5th. My little note on the homework would be, I don't see any 30s. How did you get 5 of the damn things? Do you guys see what I mean? There's no 30s over here. How'd you get 5 of them? Shit.
So you have to solve for 5 squared and
Exactly.
6 cubed.
And then multiply 25. 6 cubed happens to be 216. Blah, 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 blah. Okay, cool. How we doing? All right. Good. That's the kind of question I love. Just please ask anything that you think will be freaky, or that you just want to understand better.
What if you had, like if you have the 7, or 7 to the 4th, and then it was 7 to the negative.
So like how 7 to the 4th
And then
over
7 to negative.
negative 2.
Yeah.
All right, cool. What would I do first on this? What did I tell you? Always look for to do first. Negative powers mean you flip that thing. So I can. So does this want to move?
No.
No, he's happy where he is. So these are going to come up. So 7 4 is up there. These 2 7s come up with it. So I end up with 7. What's 4 plus 2?
Oh.
6. You guys are thinking back to here. Never do that shit. When you write an equal sign, you've got a new place where you are. You work from here. Don't think back, oh, it was negative. No, what is it now? 7 squared. 4 plus 2? 6. You don't have to think back to here and keep track of that. You've rewritten this in a better form. Then you work with that new form. That's another thing that kind of comes up sometimes. People think you have to keep track. No, the minute you write this equals something, now you work with this. Because those are the same thing. That's what that equal sign means. Does that make sense? Okay. Oh. I don't want to spend a ton of time on this next thing. Let's see how much you guys already know about this. If I say the phrase scientific notation. Oh, sorry. What's up?
I have a question.
Yeah.
So why does the 7 exponent negative 2 become 7 2?
So again, x to the negative 1 means 1 over x, right?
You're flipping, right?
Flip it,
Oh,
exactly. Any negative power flips the thing it's on.
Okay.
I like it.
Oh.
Yes.
So for the scientific notation, you know how it'll be 10 squared, right? You just move the decimal place over.
I love it.
Up top.
That's right.
How you do it the other way? So say if you have 7 million. So, because I always get confused whether the decimal point's in front of it or behind
Oh, I got you. Okay.
it. That was,
So here's scientific notation. And when I'm talking about this, we're going to finally have me shut up and let you guys work on something. Scientific notation always has to end up at something times 10 to the something. So this number here has got to be between 1 and 9. So the one way I think about scientific notation is you're sucking all the 10s out of the problem. It's like this weird-ass numerical vampire thing. So what do I mean by that? So, for example, let's kind of build up to this. Let's say I have 4,000. How do I write that in like expanded form? This would be 4 times what? 1,000, right? Let me get there with you. And of course, 1,000 is how many 10s multiplied? 3. So really, that's all scientific notation is. It's a problem that will work back out to be the number. So I always had trouble with left and right. I still actually do a little bit. When somebody's giving me directions, I have to do this because the one that makes an L is left. I have no problem telling you that. I got a lot of other shit in my brain. I just apparently didn't have room for this. I always hated when they taught left and right because depending on which way you go, you move the decimal the other frickin' way. So when it's a big number, bigger than 10, you'll have a positive power. So when it's a positive power, you'll end up with a bigger number. So let's see if I have a small number, like, what about this guy? How do I write that as a fraction? Yeah, good. Tenths, hundredths, thousandths. And 1,000 is 10 to the third. But that's not in the right form, right? I want it to be in the same exact form. So if I force those poor tens up, what's going to happen to them? I can't. Yeah, exactly. Is that cool, this step here? Math goes both ways, right? Don't judge. So if that would want to go down, well, if they force them up, it's going to be a negative. It's telling you I'd rather be downstairs, right? You guys, so that's the format for scientific notation, is number times 10 to the number. Negative power means it was small. Small number means it's going to become a negative power. Now the connection, the shortcut, please dear God, don't do this shit. Where's the decimal currently in the 4,000? It's right there, right? How many times you got to move it? Every time you move it, that is a 10. So there's 1 10, another 10, another 10. So I got 10 cubed. So you don't need this step, right? That step was just there to show you why it works. Here, and I think this is related to your question. If I stop, count 1, 2. If I stop here, is the decimal in the right place? No, it's always got to be behind one digit. So 1, 2, 3. So there's a 3. Why is it negative? Because it was a small number.
So the big numbers we go left, and the small numbers we go right.
Just move the decimal until it's after a single digit. So you don't have to memorize left and right. You just, why do I move it this way? Because I want to get it after the 4. I don't remember move it left.
So you want to get rid of your zeros.
Beautiful. I'm sucking all the 10s out of the thing. Do you see what I'm saying? That's why the number you end up with should have no 10s. If I move this twice, it would be 40. Does 40 have a 10 in it? Yeah. 4 10s. So you forgot to pull out one more 10. Let's do a couple more here. What about...
Can you do 70?
Oh yeah, just a minute. Just the number. So how many times do I move the decimal?
7 times.
Yeah, watch this. Careful now. 3, 6, 9. I want a single digit, right? I want a single digit. Does that make sense?
You want a single digit left on the other side.
Yes, a single digit right here. Not just stop when you get all the zeros taken care of, because 685 still has it's still hundreds. There's still 2 more 10s that could have sucked out of that thing. So move it over 3, 6, 9. So now it becomes 6.85 times 10 to the 9th. Why is it positive? It's freaking big. Right? I want to multiply by 10 over and over and over. Why does this make sense? Because this would become dividing by 10 over and over and over. Makes it small. Good. That's what I mean by just see why it makes sense. And then it's less memorization and more just why does it make sense.
The 9th power came from how many places you moved it?
Exactly. Every time I move the decimal, that is taking a 10 out. So how many total times did I move the decimal? 9 times. I like it. So if you did this in the calculator, it would come out to be this number. So, if I go the other way. Okay, so you got 1, 2, 3, 4, 5, 6. So what's that got to be? 1.2
2 to 6.
To the 6. No, to the
Negative.
times 10. Yeah, don't write this. That is something completely different. That is 1.2. It's 1 over 6 1.2s. That's not what we mean. We mean take 1.2 and divide it by 10 6 times. That's what that means. You got to have the whole thing in there for it to make sense. Is that cool? You should have seen scientific notation somewhere in your history. Okay. So let me finally shut the hell up. That'd be awesome. Give my camera a break.